Hello friends, welcome to Susan and John MathTube. We are in multiple integrals, lesson number 9, and we are going to learn something very important, that is changing Cartesian integrals into polar system. Before this, we learned how to integrate in the polar system. Now we are going to learn how to convert Cartesian into polar and the same logic evaluate the polar integral. Okay, so the basic things that you should know is the polar transformations which we derived in one past video, that is x is equal to r cos theta, y equal to r sin theta. So this will transform r theta into x and y, and r is equal to root under x square plus y square, and theta is equal to tan inverse y by x. Okay, and the Jacobian means what you call, you might have learned transformation in one variable. When you find for example in your class 11 or 12, you might make a substitution. Let x equal to t square in an integration problem. Immediately you will find dx, so that you can replace dx with that value. Okay, now in a multiple integral, there is a shortcut method to do that, and that is the Jacobian determinant. Anyway, in your syllabus they have not included the Jacobian determinant. So what we do is we just by heart the transformation dx dy equal to r dr d theta, or rather this comes from the rectangular horizontal strip and this comes from the angular strip. Okay, so this is a conversion of the differential. And remember, in Cartesian integrals we use a rectangular strip, and that is why it looks like length into breadth. And here the area will be half r square theta. So manipulating that we get this. Anyway, you have to be good with these formulae. Let's do one problem and understand clearly. The second thing, I already told you in the previous videos, like you should be very good with the curves in the polar system. Anyway, for your advantage, I will discuss 2-3 curves now. R equal to A means it is a circle with pole being the center and radius A units. And R equal to A cos theta, it's a circle with diameter A, and it will look like this. And finally, r equal to A sin theta, it looks like this, and the diameter is A units. Anyway, there are many curves left. Please go through the curves. Okay, now let's start. Change the Cartesian integral into polar and hence evaluate. So the question goes like this: change the Cartesian integral into polar and hence evaluate. And the integral is given by 0 to a, 0 to root under a square minus x square, y square into root under x square plus y square, dy dx. So look at this, they have asked this question 3-4 times, more than 2 times anyway. Okay, now look at this. I think you watched lesson number 8. In lesson number 8, we learned changing the order of integration. Now I'll tell you the good news. The first part of this problem, that is changing Cartesian into polar problem, is the same. It's the same like changing the order. So the first thing to do is identify the limits. I told you a trick. If you see x in the variable limit or the inner limit, it belongs to y. And of course, this belongs to x. And we will write the limits one by one. If you did not watch lesson number 8, I will strongly recommend stop the video right now and go back to lesson number 8. So we have a square minus x square x equal to 0, x equal to a. And this is the only limit with variable on both sides, so my maximum focus will be here. So I told you we have to manipulate by squaring, by cross multiplying, etc., etc. Anyway, I'm going to get y square equal to a square minus x square. That is x square plus y square equal to a square, a circle with center, origin, radius a. Changing the order of integration and changing into polar, the first part is same. Okay, now the second thing. The inner limit belongs to y. The variable limit belongs to y. That means the strip is parallel to the y axis. So now I got a clear idea, the strip is parallel to the y axis. Now look at this, the strip moves from x axis to circle. So what is the height of the strip? X axis to circle, x axis to circle. Now another information, what do you call, it moves from x equal to 0 to x equal to a. That is obvious now. This is the strip. All the conditions are satisfied. Look, the strip moves from x equal to 0 to x equal to a. And the bottom of the strip is on the axis and the topmost point on the circle. And the name of the circle is, okay, that's it. That's it. Now what you do is you write the title, changing into polar. So what will you write? Changing into polar. And now the compulsory part, you write the polar coordinate transformations are, write all the transformations, x equal to r cos theta, y equal to r sin theta, r equal to x square plus y square under root, or you can write r square equal to x square plus y square, and tan theta is equal to y by x. And finally, the differential transformation Jacobian r dr d theta. So you should write all these things. And now we have the picture, right? The picture is x square plus y square equal to a square. The first thing to do is you transform the picture. So look at this, x square plus y square equal to a square. Now look at the transformation. You can see that x square plus y square is, okay. Now take square root on both sides, go for the positive root, r equal to a. I told you, you should be good in polar language. You will be able to do these problems successfully, very easily, if you just go through your first semester engineering book, where they talk about all the polar curves, like cardioid, like circle, lemniscate of Bernoulli, everything. So if you are very good at it, you will enjoy these problems. Anyway, for you, I have already given you a hint. R equal to A is a circle with center, origin, radius A. So here we go, we make the picture. I forgot to write one thing. I told you, we start just as we start changing order. But I'd write something very important. I'd write like this. Region of integration is the first quadrant of the circle. Now I have converted it, and there is no first quadrant, second quadrant here. So I can understand. I have to take the equivalent portion. So this is what I have to consider. Look at this. This is the region of integration. And I'm sure you still remember how to integrate in polar coordinate system. What we do is we make angular strip. The logic is very simple. It is like sweeping. So I'm going to start sweeping. I start from here and I move like a broom. Okay, so 0 to 90. I think you can see very clearly the angle is from 0 to 90. I hope it is very clear. So here we go, we have our angular strip. Theta varies from 0 to 90 degree or pi by 2. Now it is obvious, it's obvious that r varies from pole to circle. R varies from pole to circle. Now pole means the coordinate of pole is actually r equal to 0, theta equal to 0. So pole means r is equal to 0 and circle means r is equal to a. We just converted it, right? R equal to a. That's it. That's it. We already transformed everything. Now what I do is, instead of writing the Cartesian limit, I'll go for my new limit. And I hope you remember, we should write theta first. And then we write the values of r. Now comes the fun part. What is y? We are not allowed to write y. We are in polar coordinate system. So I go for the transformation. Okay, y is equal to r sine theta. So I replace y with r sine theta the whole square, because we need y square. And then again I go back. I have seen this person somewhere. I'm sure in the transformation I've seen, okay, that is r. So we have r and then dy into dx. Dy into dx, okay, our Jacobian part. Yeah, so that will be r dr d theta. That's it. Now we have a polar integral. Look, there is no x and y, only r and theta. So theta equal to 0 to pi by 2 r square r. So that will be r to the power 4 sine square theta dr. Okay, so the inner limit belongs to r. So I am going to integrate with respect to r. And that gives me theta equal to 0 to pi by 2. R to the power 4 will be 4 plus 1 by 4 plus 1. And that will be equal to, so plug in the upper limit. Now a is a constant. So this goes outside. And we have our favorite integral 0 to pi by 2. That is awesome, because we can use reduction formula. Look at this. You can evaluate this using two methods. I had been talking from the first semester videos. One is beta gamma function, another is reduction formula. And I will prefer reduction formula whenever there is only sine or cos. And it goes like this: 2, 1, and then if it is even number, I have to put pi by 2. That's it. My answer is pi a power 5 by 20. That's it. And those who did not understand, I'll repeat once more. Suppose I have 0 to pi by 2 sine to the power 5 theta d theta. Then reduction formula. You have to write in exam also by using reduction formula, because most of the authors, the books I have seen in Nepal, they are using beta gamma, but actually using reduction formula will be easier when you have only sine function or cosine function. And when you have a product of sine and cosine, using beta gamma will be easier than reduction formula. Okay, the trick is like this. You write 5, 4, 3, 2, 1. And if the power is odd number, that's it. This is the answer. At the same time, if the question was 0 to pi by 2, sine to the power 6 theta. Same trick. 6, 5, 4, 3, 2, 1. And when you reach 1, you multiply by pi by 2, because it's an even number. Okay, that's it. Now let's go for the next question. Evaluate the integral by changing into polar coordinate system. It looks a little bit complicated. So before we start, I will discuss something from your class 11. Okay, point number 1. It will be very good with this line. This line is y is equal to x. And the angle it makes with the x-axis, or the inclination, is 45 degrees. And the slope of the line is 1. Okay. Now, the next thing, the general circle which you have learned long back. Long back means 2 years back in class 11. So we have a circle x square plus y square plus 2gx plus 2fy plus c equal to 0. Now remember, this represents a circle with center minus g minus f and radius root under g square plus f square minus c. So if you do not know these things, or if you have forgotten these things, it's better that you note it somewhere. Okay, now let's go to the problem. What's the first thing to do? Let it be change of order, let it be change into polar. The first thing is identifying the limits. So here we go, we have x equal to 0, x equal to 1, y equal to x, y equal to root under 2x minus x square. Now look at this, there are two very important limits, limit which has variable on both sides. There is nothing to manipulate. I already told you y equal to x represents a line passing through the origin inclined at an angle 45 degrees. And for the second one I have to do a little bit of manipulation. It gives me x square plus y square minus 2x equal to 0. I just squared and took everything to the left hand side. I'll put it in the form of the general equation so that you will feel a little bit more comfortable. X square plus y square plus 2gx plus 2fy plus c equal to 0. And that gives me the center to be 1, 0. You can calculate, it's not a big deal here. And the radius is root under 1. So the picture looks like this. The center is 1, 0 and the radius is 1 unit. So our circle will come something like this. So this is 0, this is 1, this is 2. Now let's combine it. By the way, we have to find point of intersection. That will make our solution more easier. So we have x square plus x square because y is equal to x. How do you find point of intersection? Find the value of one variable and plug it into the next equation. So minus 2x is equal to 0. So 2x square minus 2x equal to 0. 2x comes common, equal to 0. So x equal to 0, x equal to 1. So 2 points of intersection. Okay, so I got a rough idea already. So we have a circle and the points of intersection are, okay, this is the 1, x equal to 0, x equal to 2. So this is the point of intersection of, that means I have to draw the line approximately like this. So this is our line y equal to x. And now we have to find, okay, look at this, the inner limit belongs to y, the variable limit belongs to y. That means our strip will be parallel to the y axis. So we have a strip parallel to the y axis and it clearly tells me the strip will have a bottom point at the line and the top point on the circle. And x is going to vary from 0 to 1. So this is obvious. My strip will be here parallel to the y axis, the bottom point on the line and the top point on the circle, and it varies from 0 to 1. Okay, that's it. So we have identified the region of integration. I told you the first part will be same, but now starts the change. So please write, that is, the region of integration is above the line and below the circle as marked in the picture. Okay, now what to do? We have to convert everything into polar. So what we write is the usual dialogue, changing into polar coordinate system. Okay, now look at this, we have the bottom curve y equal to x. So we have y equal to x and the circle x square plus y square minus 2x is equal to 0. You saw that, right? We have the transformations here and now we have two important things. One is the line y equal to x and another is the circle x square plus y square minus 2x equal to 0. So y equal to x means r sin theta is equal to r cos theta. See, y value, x value. And that gives me tan theta is equal to 1. I am dividing by cos theta, and that is theta equal to pi by 4. Now look at this. In the polar coordinate system, theta equal to pi by 4 represents a line which makes angle 45 degree with the polar axis. Okay, almost same story. Now comes x square plus y square minus 2x equal to 0, our circle. What is x square plus y square? R square. And what is x? 2r sine cos theta is equal to 0. So r square equal to 2r cos theta. That gives me r equal to 2 cos theta. Oh wow, a circle, just as expected, with diameter 2. So now I'm going to draw the two things. Okay, and we'll draw the line also. What's the equation of the line? Yep, theta is equal to pi by 4. What's the equation of the circle? R equal to 2 cos theta. Now I take my broom. Where's my broom? Yeah, okay. So you can take your broom and start. And we know the region of integration is above the line to the circle. So I can see very clearly the angle should be from 0 to 90. If I put my broom properly at the pole here, you can see that the angle is from 0 to 90. Sorry, not 0 to 90, 45 to 90. This is the region of integration. So the angle varies from 45 to 90. So I'll write theta varies from pi by 4 to pi by 2. And r varies from, you can see that r varies from pole to circle, pole to circle, pole to circle, pole to circle. So you can write r varies from pole. Pole means 0 and circle means 2 cos theta. That's it. Now we are ready for the transformation. So how do we do the transformation? We take the question. Now what we do is, we write the new limits. Theta varies from pi by 4 to pi by 2. And r varies from 0 to 2 cos theta. And what is x square plus y square? R square. And what is dx dy? R dr d theta. And that's it. Now it's just integration. I'm sure you can do it yourself. So this will be theta equal to pi by 4 to pi by 2. R equal to 0 to 2 cos theta, r to the power 3 dr and d theta. So now we are ready to integrate this part. So that's going to give me integral theta equal to pi by 4 to pi by 2, r to the power 4 by 4, 2 cos theta, d theta. And that will be 1 by 4 goes outside, 2 to the power 4, that will be 16. Theta equal to pi by 4 to pi by 2, cos to the power 4 theta minus 0 will be 0 d theta. Now I cannot apply my trick. The reason that I cannot apply the trick which I applied in the previous problem is that was from 0 to pi by 2. So I had to do some hard work. I should be good in my trigonometry. And trigonometry tells me to change this into cos square theta the whole square. And cos square theta can be replaced with, do you remember from your class 9 and class 10? It will be half into 1 plus cos, double the angle. So look at this, I replace cos square theta with this. So we are going to get 4 and 1 by 4, that will get cancelled. And I'm going to expand this 1 plus 2 cos 2 theta plus cos square 2 theta d theta. I forgot that d theta here. There is another cos square theta. So what we do is theta equal to pi by 4 to pi by 2, 1 plus 2 cos 2 theta plus again 1 by 2 into 1 plus cos, double the angle. And now we can open the bracket, that will give me 1 plus 1 by 2 If I'm going too fast, you can pause the video and check the integration part. So 1 plus 1 by 2 will be 3 by 2 plus 2 cos 2 theta plus 1 by 2 cos 4 theta. That's it. Now we are ready for integration. And we are going to get 3 by 2. It's a constant, so theta. Within theta equal to pi by 4 to pi by 2 plus 2 into sine 2 theta by 2. Within the limits theta equal to pi by 4 to pi by 2 plus 1 by 2 sine 4 theta by 4. Theta equal to pi by 4 to pi by 2. That's it. This will get cancelled. So 3 by 2 into upper limit minus lower limit plus sine, okay, that will be 0, and 1 plus 1 by 8 into upper limit, okay, 0 minus 0. So the final answer is 3 pi by 8 minus 1. So that's it. I'll be back with more problems. So work out a lot of problems based on changing into polar, because these are regularly asked questions in your university examination. So I'll be back with the next video very soon. So till then, my friends, bye.